Hello everyone, welcome back to Let's Crack J in English, the channel of an academy. And let me start with my introduction. So I'm Jitendra Dikshit. I did my BTech from IIT Kanpur and I have been mentoring IIT JEE aspirants for the last 11 years. So I teach mathematics and we were doing limits, indeterminate forms in previous sessions. And I'll continue that. So today also I'll discuss indeterminate forms. So 0 by 0 we have already done in previous sessions. The standard forms we have done. Now we'll discuss some other indeterminate forms like infinity by infinity and infinity minus infinity or 0 into infinity, alright, in today's session. But before we begin, let's discuss the Unacademy subscription, alright, so type of subscriptions which you can buy on Unacademy. So if you're preparing for IIT then you can buy plus subscription as well as iconic subscription. So what is plus subscription? In this in this plus subscription you get unlimited access to the platform. That means you get all daily live access to daily live classes of all the educators who are teaching on Unacademy. So India's top educators are there, and you can follow any of the educator of your choice. All right, you can follow their course, you can attend their live classes or doubt classes, or even if you miss something, you can watch the recorded lectures. All right, so every lecture is recorded. You can download the recorded lectures and watch them offline as well. All right, doubt classes. This platform live classes are very interactive. You can ask your doubts during the live sessions, and apart from that, there will be dedicated doubt sessions as well. Live tests and quizzes will also be accessible, so you can attend unlimited live tests and quizzes on the platform. And all these courses are well structured. That means everything is pre-planned. So if you're following an educator, you can see all the upcoming lectures in advance, date-wise, time-wise, everything. So this is the unlimited access you get once you have the plus subscription. These are the subscription charges. You'll have to pay 38,500 for 12 months. Okay, so you can buy 1, 3, 6, 12 and 24 months. So 12 and 24 are the best packages. If you compare it price wise, per month price is low in these two. So 12 months is 38,500, and after 10% discount you'll have to pay 34,650. Use my code JEET1, all right, to get this. Similarly, for 2 years it is 56,000. Okay, and after 10% discount you'll have to pay 50,400 only. The second is iconic subscriptions. In iconic subscription, you get all the benefits of plus, and apart from that you get a personal coach as well. All right, personal coach, that means who will guide you, an expert who will guide you, for all the top exams you are preparing, like IIT JEE Advanced, Main or BITS. All right, so throughout your preparation you'll get a guidance, and test analysis will also be done in a personalized manner. Feedback will be given to you personalized way, to improve your time management and exam approach. And study planner will also be customized, and bi-weekly reviews will be given to highlight your progress. All right, so this personal experts guidance you get once you get iconic subscription. All right, so that is the difference, and also all the benefits of plus. So this is 56,000 is 1 year's choice for 1 year's charge for iconic subscription, and after 10% discount you'll have to pay only 50,400. All right, in 24 months you'll have to pay 86,000, and that is after 10% discount it will be 77,400. All right, use this code JEET1. Download this Unacademy's learning app from Play Store and start learning. Yes, I forgot to mention that you can attend unlimited special classes for free. If you don't have any subscription, plus or iconic, then also you can attend live classes of educators who are taking special classes on various topics. Every day a lot of special classes are going on the platform. You can attend unlimited special classes and start learning. Okay, so same platform, feel of the platform you'll get once you are attending these special classes. All right, now let's begin the indeterminate form. All right, so let's discuss some infinity by infinity form first. Infinity by infinite. So I'll discuss about the polynomials first of all. Suppose we have this a polynomial upon polynomial, polynomial upon polynomial. So in this, say x is approaching to infinity, and it's like an x raised to n plus an minus 1 x raised to n minus 1 plus so on up to a1x plus a naught divided by am x raised to m plus am minus 1 x raised to m minus 1 and so on a1x plus, okay, you can take b in this, okay, bm, so b1 and b naught. Now you can see, now whenever it is infinity by infinity form, always try to take, whenever if it's algebraic or maybe exponential also, you need to take, now you'll have see, terms in numerator are approaching to infinity every term. This first term is approaching to infinity, second term is approaching to infinity, and the second last term is also similarly in denominator also. So what you need to do is you need to take the highest degree term from the numerator common, and similarly highest degree term from the denominator common. All right, so these highest degree terms from numerator and denominator you need to take common. So if you take x raised to n common from numerator, it is going to be 1 minute first. All right, so you can think x raised to n common, then it is going to be an plus an minus 1 upon x plus an minus 2 upon x square and so on a naught upon x raised to n. So the purpose of taking this term common is that all the remaining terms leaving the first coefficient will become 0, because this was the largest term, okay, among all the terms in numerator. This was the largest term, so this x will be in the denominator of all the terms. You can see x square x raised to n, so all these terms will become 0 because there's finite upon infinity. So only en will be remaining if I put the limit. Similarly, in denominator you need to take x raised to m common, so it is going to be bm plus bm minus 1 upon x plus bm minus 2 upon x square and so on up to b naught upon x raised to m, like this. Now you can write, see, now you can write like this, x is approaching to infinity. Now you can write an x raised to n minus m, all right, into, and then limit of, you can write the limit of this function. You can read this as fx into gx, okay. So this is your fx and this is your gx. So limit of gx is what? An upon bm. So I'm writing this limit an upon bm, okay. And let's calculate the limit of this function. X is approaching to infinity. So now three cases arises. If n is greater than m, if n is greater than m, this is x will be remaining in the numerator. Then answer will be a plus or minus, because x is plus infinity, so in this case it will be plus infinity. But if I consider two cases, plus minus infinity, plus minus infinity, plus minus infinity, then it can also be plus minus infinity. But if n is equal to m, then you can say x raised to 0 will become 1 and answer is going to be an upon bm, okay. Ratio of coefficients. So if degree of numerator is equal to degree of denominator, then answer will be ratio of coefficients of leading terms, highest order degree terms in numerator divided by denominator, okay. So if n is less than m, then this will go in the denominator. 1 upon x or 1 upon x squared will be like that, and if x is approaching to infinity, it will become 0. So answer is going to be 0. So in this case, you can see in last two cases, answer will exist and it will be finite. In the middle case, the second case, it is non-zero finite number. The third case is it is 0 finite, and in the first case it is infinite. All right, so the answer will be infinite. So these are the cases to find the limits. I'll give you some examples. So first example is say you have x raised to 4 minus 3x square plus 1 divided by x raised to 6 minus 4x square plus 5. X is approaching to infinity. Answer it. What is going to be the answer? Example 1. These are very simple questions, but this concept is important. Taking common the highest degree term. Okay, so because I'll give you some other examples also in which it won't be polynomial upon polynomial, but we'll apply the same concept. Whenever you have terms in which one term is approaching to infinity and second is also approaching to infinity, but I'll have to compare which one is greater, which term should I take common so that it will make the other term 0. Okay, so this concept is important. So I'm giving you some examples, you just try to answer them. X raised to minus infinity, it is x raised to 7 plus 4x square minus 2 divided by x raised to 4 plus 3x. Alright, so let's discuss the answer of the first one. In this, it is pretty simple because degree of numerator is less than the degree of denominator. So answer is going to be 0 anonymously, right? There's no doubt about it. It is going to be 0. Now when x is approaching to minus infinity, let's come to second. So if you come to second, then let me make some constant here, 3 and 4, okay? So if you take x raised to 7 common from numerator and x raised to 4, then it will be x raised to 3. And remaining limit of the remaining will be 3 by 4, okay? 3 by 4. Do you remember that? This one I've written in this form, okay, after taking common. So and then x is approaching to minus infinity. If you put minus infinity in this, minus infinity cube will be minus infinity and multiplied to a positive number. So answer of this is going to be minus infinity. All right, minus infinity. You need to write with sign because in options infinity or minus infinity will be given. Now this one, the third one. I hope second is clear. So now third one. In third one, again degree of numerator is greater than the degree of denominator. So if you take x raised to 6 common from numerator and x raised to 3 common from the denominator, it is going to be x raised to 6 minus 3. And coefficient of a leading term x raised to 6 is 4 in numerator, and coefficient of leading term x cube is minus 1 in the denominator. This is x approaching to minus infinity. Now see, this is x cube again, okay, this is x cube again, x approaching to minus infinity, x approaching to minus infinity, and it is x cube into minus 4. Now see, this is minus infinity multiplied to minus 4, so it will become plus infinity. So I think you must be understanding that I'm trying to focus on this plus infinity or minus infinity, okay? So you need to write the ratio of coefficients, try to learn this. Try to write in this particular form and then answer. Try to write in this form, okay, like I have written it here, and then you need to answer. Yeah, if degree of denominator is greater than the degree of numerator, then there's no point, you can directly write the answer. And similarly, if degree of say x raised to 7 minus 4x square by plus 1 divided by 4x raised to 5 minus 3x raised to 7 plus 2, like this, and x is approaching to infinity. In this, x raised to 7 and x raised to 7 will get cancelled, right? So you directly need to write, you'll get x raised to 7 minus 7 and ratio of coefficients, which is 1 upon minus 3, all right? So this will be 1 and answer is going to be minus 1 by 3 directly, right? So in this case, ratio of coefficients will be the answer. So these are some examples based on polynomial upon polynomial. Now I'll give you another examples. Okay, now we will use in these concepts infinity by infinity form. Okay, now suppose it is given that x raised to 4 plus 1 minus cube root of 4 x raised to 6 8 actually 8x raised to 6 minus 3x square divided by square root of uh, say fourth root of x raised to 8 plus x raised to 4 and plus square root of cube root of x square, x raised to 4 plus 1. Okay, this is the question. X is approaching to infinity. Try to find the answer of this. This is also infinity by infinity form. Clearly you can see expressions are algebraic expressions. In numerator, all the terms, two terms you have in numerator and two terms in denominator. So both the terms in numerator are approaching to infinity and both the terms in denominator are also approaching to infinity. Okay, so ultimately it is infinity by infinity form. Okay, so you need to use the same concept which you used in polynomial upon polynomial by taking common the highest order degree, the highest degree term of x. So similarly here also you need to do the same. All right, so let's do it. Take x raised to 4 common from this term and from this x raised to 6. All right, so x square will come out. Okay, so x square will come out overall and this is going to be x raised to 4 this is going to be now so highest order term is x raised to 4 in the first one, so that you have taken common and it's going to be 1 plus 1 upon x raised to 4 and the highest order term is x raised to 6, so which you take common and it is going to be minus of cube root 8 minus 3 upon x raised to 4 like this. All right, and x square will come out from both the terms. In denominator, x raised to 8 you need to take common, so it is going to be x square. All right, and under root of 1 plus 1 upon x raised to 4 and plus from this you need to take x raised to 4 common, so x raised to 4 by 3 will come out. Okay, and it is 1 plus x raised to 4. So if you take x square from denominator, because in this term you can take x square, and from this term even if it is of less degree, then overall x raised to 2 you can take common. So if you take x raised to 2 common, then x raised to 2 will be here in the denominator. All right, and it will make this term 0 because degree of numerator is x raised to 4 by 3 and degree of denominator is x square, and this term is actually approaching to 1, so it is ultimately 0. All right, this term, last term, this x square and x square in this case will get cancelled, and let's find the limit. So now we can put the limit x is equal to infinity, and this first term is going to be under root of 1, which is 1, And second term is cube root of 8, cube root of 8. So I'm writing like this only. You can see this 8 will be remaining, this will become 0. And similarly here also this will become 0, so under root of 1. And this last term, as I was telling you, that because of this x squared, this whole term will become 0. So this whole term will become 0, right? So it is now 1 minus 2 divided by 1, which is minus 1, okay? So that was the limit. So I hope you understood this. I'll give you one more example based on this. Now suppose you have fourth root of right, I guess. Next is approaching to infinity. Now try this one. A similar question. All right, so let's do it. So here's degree term is x raised to 4 here. Here is x raised to cube. Here it is x square. And here it is x square. Okay. So take these terms common. So if you take x square common, what would you get? X you would get outside x raised to 4 whole raised to 1 upon 4. Okay. So it is going to be 16 plus minus actually 16 minus 4 upon x. Okay. That will be the remaining. So 16 minus 4 upon x will be remaining here, and from this you need to take again x square common, so x will come out, and it will be under root of 4 minus 3 upon x. All right, so now you can see overall x will be common, In these two, you can see x is the highest term, so it is same. You can take x common from this. Similarly, from denominator, if you take x cube common, and x will come out, and it is going to be cube root of 3 minus 2 upon x square, plus if you take x square common, okay, so x raised to root x will come out, x square whole raised to x square whole raised to 1 by 4, so that is x square, x raised to 1 by 2, which is root x. All right, so root x will come out, and it is going to be 4 1 plus 4 upon x square. All right, fourth root. Yes. So in this, you can see this term is having x raised to 1, and this is x raised to 1 by 2. So overall x you need to take common, okay? Highest of these two, you will take common. The second term will vanish because it has only root x. So root x will go in the denominator as well, right? Remaining overall after taking x common. So that will make it 0. So fourth term is again going to be 0 like the previous question. So if you take x common, so x, let's cancel x, okay, by taking it common. So if you divide by x, numerator and denominator, then remaining expressions are going to be under root of 16 minus 4 upon x plus under root of 4 minus 3 upon x. So I have cancelled x, divided by cube root of, this was fourth root, cube root of 3 minus 2 upon x square plus fourth root of 1 plus 4 upon x squared divided by root x in this, right? Because we have root x upon x. Now x is approaching to infinity. Then it is going to be fourth root of 16 is going to be 2. Okay, plus the square root of 4 is going to be 2 divided by this cube root of 3. So cube root of 3 and plus 0. Here is like a 4, finally 4 upon cube root of 3. Alright, so that is going to be your answer. So I hope it is clear. I'll give you another example based on this. This is a very good example. Next example is very good. Now suppose it is alright. Now think about it. X is approaching to infinity. What is the answer of this? Although it's very simple, but yes, you should know some basics to do it. Alright. Now listen to this. So if you remember that x raised to n divided by e raised to x, x is approaching to infinity, where n is a natural number. In fact, any positive integer you can take. This approaches to Even if you take negative, then also answer will be. But I'm saying that if you take n is a natural number or polynomial, or okay, let me write any real number. It doesn't matter. N belongs to R plus. Even if you take R, then it will work. No problem. Okay, no problem. So this approaches to 0 because e raised to x is very large compared to x raised to n. No matter if you write x raised to 100 or x raised to 200 or x raised to 1000, e raised to x will be very large compared to any monomial. Okay, any monomial. And if you write x raised to minus 100, then obviously it will come down and it will definitely make it 0. Okay, so that's why I've written R, all real numbers. Similarly, if you divide ln x, if you divide ln x by x raised to n, all right, now in this n is a natural number. Okay, so x raised to n is ln x is divided by x raised to n, and x is approaching to infinity. Okay, or at least positive number, n should be a positive real number. Then this approaches to 0. Ln x is very less compared to x raised to n polynomial. Okay, and of course ln x, when ln x is divided by e raised to x, then it will be 0. So this is the order. This is the order. E raised to x is larger than x raised to n, and that is larger than ln of x. All right. In this, let's consider n is a positive integer. All right, n is a natural number. Let's take. Okay, so that is the order. So x approaching to infinity. In x approaching to infinity, if you are dividing a smaller function by e raised to any function by e raised to x, that will be 0. So now you need to know that this is approaching to infinity, this is approaching to infinity, this is approaching to infinity, this is also approaching to infinity. Similarly, in denominator, all four terms are approaching to infinity. So now which one is the largest? Which should you take? Which term you should take, or which function you should take common, so that it will make all the remaining three 0, while when it will go to the denominator of these remaining three. So that is e raised to 2x. All right, e raised to 2x, that is the term. So you need to take e raised to 2x common from numerator as well as from denominator. So it is going to be 3x square upon e raised to 2x plus ln x upon e raised to 2x plus e raised to x upon e raised to 2x plus 1. Now from denominator also, 2 upon e raised to 2x plus x cube upon e raised to 2x plus 4 upon e raised to x. If you cancel e raised to x, yeah, or you can write e raised to x upon e raised to 2x minus 2. All right. So now these two terms will get cancelled and x is approaching to infinity. Apply this limit. So you can write now these terms are approaching to 0 using the information which I have given you here. All right, use this. So you can write 0 plus 0 plus 0 plus 1 divided by 0 plus 0 plus 0 minus 2. So what is your answer? Minus 1 by 2. So it's a very good question. I hope you got it. Now let's do it. Now let's do the next example. Next example is again going to be very interesting. So it is going to be 4 plus e raised to 1 upon x plus e raised to 2 upon x plus 4 times of e raised to 3 upon x divided by 2 plus e raised to 1 upon x plus e raised to 2 upon x minus 2 into e raised to 3 upon x, when limit x is approaching to 0, not infinity. Limit is 0, but 1 upon x will be infinity, right? I'm not saying anything. We just figure it out. See, what is the difference when x approaches to 0 plus right hand limit? Zero plus. Then 1 upon x approaches to infinity, and e raised to 1 upon x approaches to infinity. When x approaches to 0 minus, 1 upon x approaches to minus infinity, and e raised to 1 upon x approaches to 0, because e raised to minus infinity is 0. Okay, so that is the difference. So in this case, right hand and left hand limit you'll have to calculate separately. So for right hand limit, okay, when x is approaching to 0 plus, you know, e raised to 1 upon x is approaching to infinity, e raised to 2 upon x will be larger than that, and e raised to 3 upon x. So now 4 plus e raised to 1 upon x plus e raised to 2 upon x, or you can do one thing. Let me tell you what. For right hand limit, replace x by 1 upon h. All right, so when x is approaching to 0 plus, then h will approaching to infinity. All right, so now your limit will become h approaching to infinity, 4 plus e raised to h plus e raised to 2h plus e raised to 3h divided by 2 plus e raised to h plus e raised to 2h minus 2 e raised to 2h, all right, 3h. So now you know e raised to 3h is the largest term. So you need to take e raised to 3h common from numerator as well as denominator. So e raised to 3h from denominator, e raised to 3h from numerator, you take common. Then it is going to be 4 upon e raised to 3h plus 1 upon e raised to 2h will be remaining in this. E raised to h will get cancelled. 1 upon e raised to h and plus this was 4, I think. Yeah, 4. This will be 4 remaining. And in denominator, it is going to be 2 upon e raised to 3h plus 1 upon e raised to 2h plus 1 upon e raised to h and minus 2 up 2 only, right? Minus 2. Now these terms will get cancelled, and this will approach to 0, this will approach to 0, this will approach to 0. So 4 will be remaining in numerator and 0, 0, 0, minus 2 in the denominator. So minus 2. So right hand limit you are getting minus 2. Now let's calculate left hand limit. So for left hand limit, what are we going to do? We'll replace again x by 1 upon h, and when x is approaching to 0 minus, h will approach to minus infinity. Remember that. So now your question is h is approaching to minus infinity. All right. The question will be same. 4 plus e raised to h plus e raised to 2h plus 4 e raised to 3h divided by 2 plus e raised to h plus e raised to 2h minus 2 e raised to 3h. Now see which particular form is this. E raised to h when h approaching to minus infinity approaches to 0. So these terms are approaching to 0 basically now. So this is not even indeterminate form. This simply is 4 plus 0 upon 2 plus 0. So it is 4 upon 2 only, right? So answer is 2. So left hand limit is 2 and right hand limit is minus 2. That means limit does not exist, alright? So limit does not exist. I hope you have got it, alright? Okay, one more question. Alright, this one. Try this very easy version. I hope you won't do any mistake in this. All right, so let's do it. This is very simple. So it is basically sine of 1 upon x upon, okay, 1 upon x. So can you do it like this, sine of infinity? So sine of, this is sine of infinity upon infinity, right? Or you could do it here only. Sine of infinity is basically some number between -1 and 1. This number is between -1 and 1, and this denominator is infinity. So some finite number divided by infinity will approach to 0, or obviously approach to 0, right? Or you can do directly also. This number is approaching to 0 into some number which is -1 to 1. Okay, number between -1 and 1, finite number, right? So 0 into finite is 0. So in this way also you can answer. So it was pretty simple, all right? Very simple to answer. All right. So the next indeterminate form will continue in our next session. All right. And in that we'll discuss infinity minus infinity form. Okay. And some other forms like 1 raised to infinity and 0 raised to 0. Okay. So we'll continue tomorrow. Uh, so thank you very much for attending the session. Right. Thank you very much for attending the session. And like and subscribe the channel and use my code JEET1 if you are getting plus or iconic subscription. All right. Get instant